It's not hard. It's not fun.
I'll tell you,
It's not hard.
it's not fun.
Okay, so here's your figure. I think we found most of the slopes the other day, but the first thing we're going to do is find J prime. So J prime is what? Using this formula, what's J prime? G prime of x, f of x, all over x squared. Okay, now if you got some of these wrong, it could be that you got the wrong values from the very first time, because that happens. All right, part A, J prime of 1. Okay, so basically, we're going to take this, and we are going to put in a 1, right? Not what I wanted to do. All right. Went to group. Groups. Now I'm going to club. Okay. All right. So this is it, except I'm going to put in a 1 for all these x's. Right? 1, 1, 1, 1, 1. All right. G prime of 1. G is this piece, right? What is G prime? That means it's the slope at 1. What is this? What did we say the slope of this was? -1. Right here it is. M equals -1. So we put in a -1 there. F of 1. F is the other function. This is F. Okay, F of 1 we decided was 1. Okay, minus G of 1. We're up here. Did you all decide it was 3? And F prime of 1 is the slope of this line, which is 2. All over F of 1, which is the second number squared. Okay? So the primes are your slopes. The other ones are just the values there. So what's that? -1 minus 6 over 1, -7. Is that what y'all said? Okay, wait. Let me look. Okay. Yeah, 2 was right here. This was 2, right? Yeah. Anything else? That was 1. Wait. No. 3, 2. Okay. All right. So what is that? -2 minus 6 is -8. Right. Over 4, which is -2. Okay. All right. Part B. We are going to take that and clone it again. And now we're going to. Oh, wow.
I figured out what I did wrong. I put the wrong slope.
Yeah, it's very easy to do that.
I'm going through and fixing it now.
All right, so on here we're going to do part B. We're doing 2, right? So this is 2. Two. Okay, so we're going along. G prime of 2. What did you say that was?
-1.
G prime of 2 is -1 again. Okay, F of 2. What did you say that was? 4. Minus G of 2. And F prime of 2 is the problem. F prime of 2 is at the corner. So what does that mean? does not exist, I'm done. Okay? Because I can't throw that in there. So that's part B. All right, C. One more time, let's clone here. Why that doesn't want to show up. You all got it? What are you doing wrong? Putting in the wrong values or?
Yeah.
So should we finish or not? Yes, okay. Now, the third part is 3. All right, G prime of 3. G prime of 3 is the slope of this line, right? Just still -1. F of 3. F of 3 is the blue function. What do you put for the F of 3? 2. Okay. Minus G of 3. That's the green function over here. G of 3 is 1. And F of 3, F prime of 3, slope at 3, which is this piece. Slope is -2. All over F of 3 squared, which was 2. So we got -2 plus 2 is 0. 0 over 4, rather, is 0. Okay. All right. Okay, so let's finish up. We didn't get too far. I believe we were talking about the unit circle when we last left. Okay. All right. We squeeze in here, but can everybody get these values pretty quickly? You start up and go up. So you start up at the top and go up 1, 2, 3. And then the other one is opposite, 3, 2, 1. We divide everything by 2. We take the square root of everything. Okay. Now, another problem is, what is the first one here? What angle is this? Pi over 6 is the little one, because remember, you're dividing pi, which is 180. That's that 30 degrees. Pi over 4 is the second one, which is 45 degrees. And what's the third one? Pi over 3, which is 60. Okay. There's no shame in having to draw this still. Okay, you have a lot of stuff to remember. I would have to think about it, and I've been doing this for a long time. Okay. Now, there's no point in memorizing all of these values. If we can come up with all these and these 3, we can put it in any quadrant because we know this acronym, what does it stand for? Okay. Y'all, have you heard of that? Okay, well, this is the best thing that you need to remember in remembering your SIGNs of your things. All means all functions are positive. Sine, cosine, and tangent. Okay, now of course, which sign becomes the sign of SIGN, which other one is the same as the sign of the SIN? What is the, we are doing that, what is the SIGN of the sign in the first quadrant is positive? Which other function besides not sine, tangent, cotangent has the same sign, SIGN, as sine? Isn't there 3 other functions other than sine, cosine, and tangent? What's the other one? Cosecant has the same. Okay. So if you have cosecant, that's all right. Now S stands for sine. Sine is positive in the second quadrant. What does that tell you about cosine and tangent? They're negative. So are their reciprocals. Cosine's reciprocal is what? Secant. Tangent reciprocal is cotangent. Well, we're going to focus on the 3. Okay, T stands for tangent. Tangent is positive here. What does that tell you about sine and cosine? They're negative. Okay? And then C stands for cosine. Cosine is positive. That means sine and tangent and the reciprocal function. values are negative. Okay? So we use that a ton. All students take calculus. Okay, that's just about the signage. Okay, that's how we can remember these three and then just put the positives or negatives in these three quadrants because that's all that changes. Okay, all right. Is there a question? You're good? Okay. All right, let's find the values with your unit circle. You should know any of those values, and you shouldn't have to look any of them up. But certainly you can throw them in your calculator just to check while we get back into this. But all right, tangent of 45. So the first thing I would do if I'm making one is I'd say, all right, where's 45? 45's in the middle. It's not this one, and it's not this one. But while I'm here on this page, let me just write these out. This is pi over 4. What are the sine and the cosine of pi over 4? Radical 2 over 2. Okay. All right. So what's the tangent? Oh gosh, that's the sine and cosine. What's tangent have to do with? Okay, because it's sine over cosine. You didn't remember that. But hopefully you're not going back that far that you don't remember that. Okay. The sine of pi over 6. Which one is pi over 6? The little one or the big one? The little one is pi over 6. Okay? We started up. 1, 2, so this must be radical 3 over 2. And the other one would be, its pair would be 1/2. Okay? So you can kind of do that in your head. I'm starting up. I know I'm at the third one. So what's the sine? 1/2. Okay? Cosine, pi over 2. Where's pi over 2? Right here. Remember what that quadrant, we have a unit circle, 0, 1. So what's the cosine? Cosine is the first value. It's cosine sine. Okay? I'm not losing any of y'all in my, good. All right. Tangent of pi. Where's pi? Right here. What are the quadrants coordinates there? -1, 0. So sine over cosine gives me a tangent of pi to be 0. Okay? All right. Remember, a negative goes this direction. Okay? But it's still the same pi over 6 value. So a cosine in that fourth quadrant, I'll just write fourth quadrant here, should have the same cosine as pi over 6, which is which one of those? Radical 3 over 2 or 1 over 2? Radical 3 over 2, good. And since it's in the fourth quadrant, we say all students take calculus, cosine is positive, we're good. Does that make sense? We remember the angles by just these three guys, and then we remember the sine by all students take calculus. Sine of 60. 60 is right here. So we start up. We never finished that because we never needed it. So what's the sine of 60? Radical 3 over 2. Okay? Cosine of 3 pi over 2. Where's 3 pi over 2? Right here. Coordinates are 0, -1. Cosine is 0. Very good. Tangent of pi over 3. Pi over 3 is the same one as 60. So what's the tangent? It's radical 3 over 2 over 1 over 2, which is radical 3. I don't know about you, but I don't have the tangent ones memorized. I just put sine or cosine down. Okay? So that's, those are going to come up just randomly because now we're going to do some derivative of all those.
Oh my God, no, we're not.
I'm not joking. I would never joke
That is
about that. Okay. Now this,
oh my God.
right here, is a monster. Okay? There's the bottom line. If you don't remember the bottom line, then you got to do all this. So I suggest you just remember the bottom line. And I'm not even sure you're even that interested in it. So let's get to the bottom line. Derivative of sine of x equals this. What is that? What is the limit as h approaches 0 of cosine of x? There's no h. How do you find the limit of something if we're approaching h?
Use the definition of x.
Yes, Kinsey. Cosine of 0. Cosine of x. The derivative of sine of x is cosine of x. Okay? Now, that's what you got to remember. This is all the algebra that went into figuring that out. No one wants to ever see that or do it again, including myself. Okay? It's not 1. It's cosine of x. There's quite a difference. Okay? The derivative of sine is cosine. Because there's no h, so the limit as h approaches 0 of cosine is cosine. So, because there's nothing to plug in, it's just that. Okay. No, I'm not going to explain it anymore. I'm going on because you're all stressing out about it, and there's no point. Here's what we're going to remember. The derivative of sine is cosine. Okay? That's all you got to remember. Thank you, Emma. All right. Derivative of tangent is secant squared. Okay? Just got to remember it. Derivative of secant x is secant x times tangent x. Okay? How did we? Do you really want to go there?
No, I don't.
That's how you do it. Okay? I'm just saying. That's right. Okay. That's how you do it. Okay. Otherwise, we memorize. We can do that, right? That's the lowest form of learning something.
Oh my.
All right. It is. Oh, it is. Okay. All right. Derivative of cosine. Any guesses what's the three that are left? Negative sine of x. Good job, Molly. Okay. What about cotangent? Which one of these two? Negative cosecant. Good job. And negative cosecant. X cotangent. Okay. Now, there is. You got to remember. You got to just remember. Okay. There's not, the only thing that I would tell you, remember this, is all the codes over here, what are they, what do they have it all in common?
Negative.
Good. Okay, so remember that the derivatives of the co-functions are negative. The other ones are positive, but that's all I got. But again, it's just a memory thing. You just go work on it and remember it, and then you got it. Okay, because we don't want to go back to the page of going through the definition derivative. That is your alternative if you don't remember. Okay, so we're also, I wanted to remind you here, the sine and the cosine function are differentiable for every x. Remember what those look like? You know, they look like this, and there's derivatives everywhere. Okay, cosine just bumps it up, looks like this. Okay, but some of these will have gaps. Remember what tangent looks like? It looks like this, and then it skips and looks like this. Remember? Okay, and you're going to have gaps here. That's really bad. But so just keep that in mind. There's going to be some places where you're like, oh, we don't have a derivative there. Okay, we're not going to have a derivative at every hip stitch on that one. Same with, remember what the secant x is? This is sine. Remember those that look like this? That's me, sorry. Okay, they're going to have places where they don't, you know, again, you're not going to have a derivative. Which one is this? This is secant, so that would be cosine, cosecant, sorry. Anyway, so just keep that in mind. You may have times where you're not going to have a derivative show up. All right, so let's throw the trigs. That's all the theory we have. Now it's just example time. Okay, we're going to throw the trig functions in with our product rule, our quotient rule, our sum, difference, all that. We're just adding layers onto your derivatives. Okay? So y equals x squared times sine of x. We're looking for y prime. What should we use?
The product.
Product rule. Go ahead, Emmett.
2x sine x plus x squared.
Nice. Oh, yeah. Okay. We have to do that.
Like, isn't that make up the same answer if we just do 2x and 2x?
Is that the same as that?
No, I'm saying it.
You have to do the product rule if there's a product. Okay? Now, what if we were, that's it. Yep, that's y prime. Okay? Let's, we'll come back and add something to that a little bit. Right. I mean, you could simplify and plot x, but, you know, what good is that going to do you? At this point, you're good. Just leave it alone. Okay? All right. Good job, Emma. 9. Okay. Y double prime we're looking for. Y equals secant theta. Okay. Y prime equals what, Holly?
Secant theta.
Okay. Your theta is like your x, but please don't, please don't say, oh, I'm going to use x. You've got to deal with the variables that they give you in this case. Okay, now, y double prime is the derivative of the derivative, which always said was secant theta times tangent theta. But we're only going to use Miss Kathleen. Product rule, nice. All right, go for it. And if you have to write it out, Emma didn't need to write it out when she did it, but if you have to, go for it. You mean tangent theta?
Yeah.
Okay, I'm going to write it out here. Go ahead.
Wait, I thought that the derivative of secant is secant theta. So it would be secant theta tangent squared.
Okay. I wrote out the step.
What?
So the derivative of secant theta is
Secant theta tangent.
secant theta tangent theta. And we have this plus, what's the derivative of tangent? Okay. All right. Now, I would probably put some of those guys together. There we go. Yep, that would be good. If you want to factor, I factor.
In this, and if it's just an addition, should be so factor.
It's not necessary, no. Some people will just do it as a habit. And I think there's some kind of a identity here, isn't there? Okay. I believe so. Maybe. Okay. So this, I don't think it's one anyway. This one is the only one I remember, but I do remember there's one with secant squared and tangent squared. How do I get that again? How do I get the other one? I divide by sine squared, what's that?
Divide by what?
If I divide by cosine squared, I get tangent squared plus 1 equals, divide by cosine squared, secant squared. Is that one going to be applied to that other one? No. The signs aren't right.
Okay, so just leave it.
Yeah, just leave it. Most of the time, that doesn't really come up, but yeah, it'll make your life easier later if you can recognize that, but now it's probably fine to leave it. Okay, where are we? Okay, here we go. So let's do f prime. We got some derivatives. Let's see. Hannah, what are we going to use? What rule? Yeah. Very good. Okay, go for it.
It will be negative sine of x times 1 plus sine of x minus cosine x times cosine of x over 1 plus sine of x squared.
Nice. Okay, now, for those of you that aren't quite there, there's no shame in writing this out. No, I would not. And the reason is because...
No, I don't know if I do it on the other one, but you know.
Yeah, no, there's no point. If there's any simplifying going on, you would want the factors anyway, so I would never multiply that out on the bottom. Okay. Good job, Hannah. All right, now, we're going to leave the bottom alone. So, Emma Sternberg, you want to multiply the top out because I can't do any canceling.
Negative sine x squared. Minus.
Wait. Are you distributing that negative sine of x?
I thought the 1 went away.
No.
Oh my bad. I said the wrong thing.
Okay.
Let me look it up there. Okay, negative sine x minus sine x squared minus cosine x squared.
You're saying cosine x squared, but you really mean cosine squared x. Right. Okay. All right. Now we have a nice identity at work here. Do y'all see it? We can. Just to be clear, we're taking out a negative. I'm just rewriting it. You probably wouldn't have to rewrite it if you're... leaving the factors alone on the bottom still. Okay, now what do we know? That's 1. That's right. That's 1. That's that identity. So what does that mean? That's negative 1 times what's left in there? Sine x plus 1 over 1 plus sine of x. It is the same. So what does that mean?
Negative 1 over 1 plus
So it ended up being that canceled with one of those. Because they're the same thing, just written in different.
It's not that bad. I mean,
So you're just adding some more derivatives that you didn't know last class. That's all. It's the same idea. We don't get, this is the simplest. When we do 3-4, it jumps up a level, but we're going to test before we do 3-4. So.
oh, that's good.
All right. Any questions, comments on that problem? All right. Okay, so let's start with some applications. Find the slope of the tangent line at x equals pi over 4. Slope of the tangent line, in other words, is the derivative. Okay. Derivative. All right. So f of x equals 4 sine of x cosine of x. I need f prime. That's my derivative. All right. Megan Hawk, you up for it? Okay. How are you going to divide it? Okay, good plan. Take the 4 with the sine of x. All right. Do you want me to write it out?
Yeah. So
I think so too. In your first beginnings, you're going to do that times that plus grab the 4 sine of x. What's the rest of it?
times cosine of x. The derivative of cosine.
Okay. All right. Very good.
4 cosine of x times cosine of x plus 4 sine of x times negative sine of x.
Nice. Okay. That's cosine squared and 4 sine squared.
You can pull out the 4 and then it's...
You can, but we are going to plug in right now, so.
Oh, it doesn't.
Pi over 4 is going for x. That's what it says they want the derivative at. Okay, so 4 cosine squared of pi over 4 minus 4 sine squared of pi over 4. Okay, here's where you need those values. Okay, so we go back over here if we still need it. Unit circle, what is the sine and the cosine of pi over 4? Hopefully you don't need to think about that one. They're both square root of 2 over 2. Okay, so.
I always get confused with the square. We have to square that?
Yes. Because this really means, let me just rewrite it. 4 cosine of pi over 4 squared. And this really means sine of pi over 4.
No, we don't actually know.
So 4 radical 2 over 2 squared. Radical 2 over 2 squared.
No, we don't actually square it out.
Yeah, you do.
What would it is? Why? So it's minusing itself. It's subtracting itself.
Oh, it sure is.
If you did square it, then like if you did it as that, would it come out as 2 over 4?
Yes. This is 2 and this is 4. Yes.
Okay.
Okay. If you didn't, that's smart of you, Emma. Okay. What are we looking for? Slope of the tangent line. Yes. So that's it then, right? The slope of the tangent is 0. Sometimes we're looking for the equation, but not the tangent line, but we're not this time.
Would you want us to go through all the extra at the bottom, or could we just write like that, what you have in black equals 0?
Yep, as long as you get, yeah, if you see that right then, do it. There's no point in going that extra trouble. Okay, that's it. All right, let's go back and to example 1. Let's do a further example. Let's find the equation of the tangent line at, let's see, what would be a good place? X equals pi over 3. It's not going to be that pretty, but give it a shot there. I'm not sure I saw it.